Hi, I am John, a new joiner. Where are my email ID and password?
Hi, I am Maria. I have been transferred to the payroll department. How can I get access to the payroll admin application?
I forgot my password. How can I reset the password?
How can I get a report of all my reportees with all access permissions?
The employee Robert left the organization 2 months back. Why is his email ID still active? John works in the admin department. Who approved his access request to the finance portal?
These are very common questions for any organization. The answer to these questions is to implement identity management for your workforce or customers. In this episode, we will discuss what is identity management, why it is important for any enterprise, how identity management is implemented in an organization. Let's us understand what identity is all about and why it's important. What are the different domains of identity management and how identity has evolved? Any modern enterprise has a wide variety of digital resources. They include from legacy mainframe systems to modern web applications, databases, directories, document stores, and various operating systems. These resources are accessed by all stakeholders in that enterprise, which includes not only employees, contractors, customers, and partners, but also various devices such as servers, network devices, firewalls, etc. Modern enterprise makes managing secure access to resources a challenging task. These challenges are simplified by identity management. What is identity management, IDM? The answer to that question is both easy and very complex. The easy part is identity management is everything that deals with managing identities in the infrastructure of an enterprise. The complex part of the answers takes the rest of this video. The central concept of identity management is usually a data record that contains a collection of data about a person. This concept has many names, but the most common are persona, user record, and user identity. Identity usually holds the information that describes the real-world person, such as the person's given name and family name. In an organization, identity is associated with an account or multiple accounts. Each account contains the technical information that relates to the operation of an information system for which the account is created. This includes the specification of the home directory and a wide variety of permission information, such as group and role membership, system resource limits, etc. User accounts may be centralized and unified, distributed and unaligned, or anywhere between these two extremes. But regardless of the architecture, the aim of identity management is the management of identity and associated accounts. Early days of computing in 1970s, access to mainframe computers was restricted to a handful of people within an organization. Of course, a locked room was usually all that was required to control access to the mainframe, and managing identity was easy. Every time it evolves, the need for identity and security evolves along with it. For example, in the 1990s and early 2000s, an organization's employees worked in office buildings. Their information was protected by a firewall installed at the perimeter between the corporate network and the internet. Employees started their day by driving to the office and logging in from their desktop computers. At the end of the day, they logged off from their desktop computers. Then people got iPhones and laptops and started working and collaborating more dynamically. Employees today read work emails on their personal smartphones, chat with friends, and send links across social media from their work laptops connected to open Wi-Fi networks in coffee shops, airports, and hotel lobbies. The day's reality in which people's personal and work lives are increasingly commingled is far removed from the well-defined and well-controlled workplace environment and network perimeter of the past. How to manage user identities and their access in today's complex environment where users are spread across globe and applications are deployed in hybrid model that is cloud as well as on-premise servers. Identity management software takes care of technical tasks that happen when a new employee joins a company, when his responsibilities change, when he leaves the company, when a new contractor is enrolled and so on. This is called identity lifecycle. The set of events and tasks that make sure that every identity has what it needs. Identity management takes care of the technical details of identity lifecycle, such as creating accounts, assigning correct groups and permissions, setting and resetting passwords and so on. The goal of identity management is to automate as much as possible, therefore reducing operational costs and improving security. Identity and access management is not a single technology. In fact, it is a wild mix of various technologies that both complement and overlap each other. There are at least three main technological branches in identity management. Identity Vault. It stores user identity information. It is usually assumed that the identity store is exposed to other systems over the network and that it is shared among many applications, but that is not always the case. LDAP directory servers, Active Directory, and portions of relational databases are examples of identity stores. Identity Management (IDM) is a branch of IAM technologies that focuses on the management of identity stores. IDM systems are complex mechanisms that synchronize account data across a broad range of data formats, models, meanings, and purposes. IDM systems usually contain sophisticated expression and rule engines, workflow mechanisms, policy evaluation and enforcement, and so on. Identity governance is an extension of identity management that focuses on business aspects of identity management. Access management (AM) deals with user authentication and, partially, authorization. The goal of access management is to unify the security mechanisms that take place when a user is accessing a specific system or functionality. Single sign-on (SSO) is sometimes considered to be a part of access management. Accounts are stored in databases called identity vaults. The underlying technologies of these databases vary, ranging from flat text files through relational databases to directory servers. Directory servers accessed by LDAP protocol are very popular because of their scalability. Identity store may be integrated with the application that is using it, or it may be a shared standalone system. A shared identity store is making user management easier. An account needs to be created and managed in one place only. Authentication happens in each application separately. However, as the applications use the same credentials from the shared store, the user may use the same password for all the connected applications. Identity stores are just that: storage of information. The protocols and APIs used to access such databases are primarily designed to be database interfaces. This means that they are excellent for storing, searching, and retrieving data. While the data and the account may contain entitlement information, permissions, groups, roles, etc., identity stores are not well suited to evaluate them. I.e., identity store can provide information on what permissions an account has, but it cannot make a decision whether to allow or deny specific operations. Identity stores also do not contain data about user sessions. It means that identity stores do not know whether the user is currently logged in or not. Some identity stores are frequently used for basic authentication and even authorization, especially LDAP-based directory systems. But the stores were not designed to do it and therefore provide only the very basic capabilities. Identity stores are databases, not authentication or authorization servers. Consider an enterprise cyber shield. They have mission-critical applications that are deployed on-premise and on the cloud. Few applications share a common identity store, which is Active Directory, while few applications have their own identity store. Their user base includes employees, contractors, vendors, and consumers. They need to implement an identity management system to manage all user identities and access to all applications. The major requirements for this organization are: the IDM system must integrate many different identity stores. The goal of IDM systems is to keep the identity stores as synchronized as possible and practical. The priority of IDM systems should be non-intrusive. IDM systems should not try to change existing account data models in the applications. IDM system should adapt its own mechanisms to match the data model of each connected system. Implementing IDM systems in this enterprise will be quite complex and need to be customizable and programmable. Adaptation of the data models is frequently done by using complex rules and expressions. Before implementing the IDM system for CyberShield, let's define and identify a few key components. Authoritative source. A repository or system that contains identity information about an individual and is considered to be the primary or most reliable source for this information. Within an enterprise, typically this is an HRMS system. For a customer's identity, it can be a customer relationship management, i.e. CRM system. Applications are the resources that a user needs to access for his job. Identity Vault is a system where the identities of all users are stored for easier management of access, roles, and permissions. An identity management system uses connectors or agents to manage identities and access among these systems. IDM systems can communicate with each application using the application's own protocol or interface. There are two basic approaches. Connectors are pieces of code running on the side of the IDM system. In this aspect, they are similar to the database drivers. Connectors expose the application's objects, accounts, groups, ACLs to the IDM system. Connectors use various kinds of remote protocols or APIs for that purpose. Connectors are non-intrusive and do not require any installation on the application side. Agents run on the application side. Similarly to connectors, agents expose the application's objects to the IDM system. Agents are intrusive and require installation and integration on the application side. However, agents can use also local APIs and may be much more powerful than connectors. Let's understand how a connector or agent works. The purpose of a connector is to provision, deprovision, or update users' access or accounts from a target application. For example, if a new identity is available in the Identity Vault, the connector will provision an account for that identity in the target application based on organization policy. If identity is disabled in the Identity Vault, the connector will disable or remove the account from the target application. The connector performs these operations in multiple steps. The first and most important one is schema mapping. The attributes of an identity may have different names in the Identity Vault and target application. The identity management developer needs to provide a mapping of Vault identity attributes and application identity attributes. For example, the UID in the Identity Vault may map to the user ID in the application, fname can map to the first name. Sometimes we may need to apply some transformation logic to map the attributes between the Vault and applications. For example, the display name attribute in the application can be a combination of fname and lname of the Vault identity. Email ID can be a combination of firstname.lastname plus organizationname.com. and so on. The governance policy or provisioning rules are a set of rules that dictate what operations need to be performed. For example, if the user belongs to the finance business unit and the role is manager, provide admin access in the application. It can also be used to send notifications to the user or his manager or system admin. A rule can be if the organizational unit is finance and the user role is manager, then provide admin access to the user account. Finally, the provisioning, deprovisioning, or update operation is performed, which is governed and managed as per previous steps. It can be creating an account with appropriate access, permission, or role. Update account or update access permission or operation can be delete or disable account. IDM systems do not deal only with the technical aspects of the integration. Policies and processes are almost always part of IDM system deployment projects. Most IDM systems include their own version of workflow subsystem customized for identity management applications. It is usually quite easy to set up rules that automatically determine the basic accounts for a new hire and let system administrators approve the creation of such accounts. Users may also request additional privileges or permissions which may go through an approval process before it is granted. The user will fill out an access request form. He can choose access from the catalog and provide a business justification for the request. On submitting the request, the IDM system will create a task for approver or chain of approvers. The approver will fill out an approval form, and he can either approve the request or deny the request with justification. If the request is approved, the IDM system will trigger the provisioning engine. If the application has a configured provisioning connector or agent, the request will be fulfilled automatically. In the absence of a provisioning connector, a provisioning ticket can be created in the ticketing system by IDM system. In this case, the provisioner or application admin will provision the request manually. This is a unique aspect of IDM systems when compared to other IAM technologies. Other technologies usually focus only on the technical side of the problem, not the business side. IDM systems are the glue that connects business and technical sides of identity management. An enterprise will have a wide variety of applications, which will have a wide variety of identity stores. Most popular identity management supports most of the widely used applications or identity stores available in the market. An IDM developer just needs to install them and configure business policies. However, he may need to do some customization as per organizational policies and legal or regulatory requirements. Based on the target application and identity store, we can categorize the connectors. The first category is native connector. The native connectors are application specific. Most of the time they are plug-and-play type connectors. You do not need to do any major customization. Simply install them, provide target application URLs or IP, and they start working. You may just need to configure provisioning or governance rules. This category includes connectors for LDAPs, such as Active Directory, Directory, Azure AD. They also include popular business applications such as SAP, Salesforce, and Office 365. Operating system connectors for Linux Unix also fall in this category. The mainframe connectors such as AS400, RACF fall under native connectors. They are used to perform user provisioning on legacy mainframe systems. The next category is web service connectors. These connectors work as web service clients for the application which exposes user provisioning APIs as web services. Based on the protocol, they can be REST-based connector or SOAP-based connector. The IDM developer needs to map API with the operation as well as he needs to map API parameters with identity attributes. If the application uses the database as an identity store, a database connector can be used. IAM developer can map to database schema with identity schema, or he can create views or write SQL queries for provisioning operation. SIM connectors are a special type of connector. SIM, or the System for Cross-Domain Identity Management Specification, is an open standard designed to manage user identity information. SIM provides a defined schema for representing users and groups, and a RESTful API to run CRUD operations on those user and group resources. File feed connectors works on user records in text file. They are one-way connectors to aggregate the user records and their access information from the application to the IAM system. They are more suited for authoritative sources such as HRMS or CRM. However, user and access provisioning cannot be done easily using this connector. The ITMS connector offloads the provisioning work to an external ticketing system. All provision tasks from IAM system create a ticket in the ITMS system. The manual provisioning team claims the tickets, does the required operation, and closes the ticket. These connectors are useful in scenarios where the applications are managed by a third party. The custom connector requires development work from the implementation team. It uses APIs from IAM tools and APIs from target applications to perform user provisioning operations. This connector should be used as a last resort as it requires good amount of development effort. Now let us see the complete architecture of identity management for our organization CyberShield. We have HRMS as an authoritative source for all identities which is administrated by the Human Resources Department. Whenever a new employee joins, a new record is created in HRMS for that employee. In case of employee promotion, transfer employee records are updated in HRMS system. If an employee retires or leaves the organization, the employee records are marked as inactive. The employee's record feed is provided to the identity management system via the connector. This connector can be a direct connector or file feed connector. In the direct connector case, the IAM system will pick the employee's records directly. In the file feed, the records are extracted from the HR system and a text file is created. This file is fed to the IAM system. Now the provisioning engine gets triggered for new or updated employee records. The governance policy or provisioning rules are evaluated and connectors are triggered to perform the appropriate provisioning, deprovisioning or disable operation. We have an Active Directory connector for email applications and another domain-joined application. For an application that uses a database as an identity store, we have configured DB connector. For a web application that has REST API for user provisioning, we have configured REST connector. For an application on the cloud that has SOAP API for user provisioning, we have configured SOAP connector. For all other remaining additional access requests, we have configured access request workflows. The managers can approve the access requests, and later IAM connector takes care of provisioning. System administrators have access to manage and oversee the overall identity management operations. Now we will detail down the major use cases of identity management. The first use case is the joiner use case. A new employee is hired and he is joining the organization. The new employee should be productive from day one, so on the joining day, he should have all the access that is required for his job. We can write provisioning policies in the identity management system so that once his identity record is available from an authoritative source, which is HRMS in our case, the new employee can get all required accounts and access. The provisioning policies can be written using multiple models. The most common are role-based access control (RBAC), attribute-based access control (ABAC), and policy-based access control (PBAC), apart from birthright access, which is minimum access required for all employees. Birthright access refers to the automatic granting of access privileges to certain resources based solely on an individual's affiliation or position within an organization. In other words, this is the standing access an employee has. It's their birthright just by existing. This method should be used for minimum mandatory access for all employees, such as a domain account, email account, access to the workplace, and access to self-service portal, etc. RBAC is role-based, so depending on your role in the organization, you will have different access permissions. This is determined by an administrator who sets the parameters of what access a role should have, along with which users are assigned which roles. For instance, some users may be assigned to a role where they can write and edit particular files, whereas other users may be in a role restricted to reading files, but not editing them. It's possible for one user to be assigned multiple roles, giving them access to numerous different files or abilities. Say there's a team of people working on a large project. The project manager will have access to all the files and can edit and change things within the project. However, the development team might only be allowed access to the programming files and won't be able to see or edit the financial information or employee details for the project. On the flip side, the human resources or management team might have access to all the employee and financial information, but has no use for the programming files. Attribute-based access control draws on a set of characteristics called attributes. This includes user attributes, environmental attributes, and resource attributes. User attributes include things like the user's name, role, organization, ID, and security clearance. Environmental attributes include the time of access, location of the data, and current organizational threat levels. Resource attributes include things like creation date, resource owner, file name, and data sensitivity. Essentially, a BAC has a much greater number of possible control variables than RBAC. A BAC is implemented to reduce risks due to unauthorized access, as it can control security and access on a more fine-grained basis. For example, instead of people in the HR role always being able to access employee and payroll information, a BAC can place further limits on their access, such as only allowing it during certain times or for certain branch offices relevant to the employee in question. This can reduce security issues and can also help with auditing processes later. Policy-based access control, PBAC, is another access management strategy that focuses on authorization. Whereas RBAC restricts user access based on static roles, PBAC determines access privileges dynamically based on rules and policies. Although PBAC is fairly similar to a BAC requires more and development resources, e.g., XML coding, as the number of required attributes increases. Let's see how joiner use case will work in CyberShield. A new employee is hired and he is joining the organization. In our use case, HRMS is an authoritative source that is managed by HR admin. HR admin will create a new employee record in HRMS system and fill in all information of the new employee, such as his personal details, first name, last name, and date of birth, along with job details such as business unit, job role, job title, reporting manager. Using HR connector, the new identity record is picked by the identity management system. Once a new identity record is available, the identity management system will start evaluating the governance or provisioning policy. The governance policy will decide which access the new employee will require as per policy and ask the identity management system to provision the access. The basic minimum access that an employee requires is called birthright access. The birthright access includes access to work location, office premises, email account, domain account, self-service portal, etc. The new employee will be provisioned access required as per the role assigned to him. If he is hired as manager, in that case, he will get access to approve requests raised by his reportees. The new employee can get access specific to his department. This is a case of attribute-based access. If the new employee joins the finance department, he will get access to applications managed by the finance team. Another example is that if the requester is an accountant, then allow read-write access to financial data. Let's consider another scenario. Employee got transferred from the marketing business unit to administration business unit. Or employee got promoted to manager role, or employee got transferred from New York to Chicago. HR admin will update employee records in HRMS system and update all information that is changed, new business unit, new role, or new location. Using HR connector, the updated identity record is picked by the identity management system. Once an updated identity record is available, the identity management system will start evaluating the governance or provisioning policy. The governance policy will decide which access the employee will require an update and ask the identity management system to update or revoke the access. For example, the transferred employee will need access in Chicago office premises, but access to the New York office will be revoked. His role or group will require an update in Active Directory. He may get added to new groups in the Active Directory as per policy. The governance policy will decide which access is no more required. It can be role-based, attribute-based, or policy-based. The access permissions that are not as per the new role or identity attributes or policy will be revoked. He may be removed from old Active Directory groups. His access will be revoked from applications that were provisioned as per his previous business unit, old role, or location. The governance policy will decide which access the employee will require for his new business unit, new role, or new location, and ask the identity management system to provision the access. The third important HR process is leaver. Once an employee leaves the organization, his all access must be revoked, his identity must be deleted or marked as inactive. For audit and compliance purpose, his identity can be archived. HR admin will mark the employee as inactive. Using HR connector, the updated identity record is picked by the identity management system. Once an updated identity record is available, the identity management system will start evaluating the list of all access the employee has. The governance policy will ask to revoke all access including birthright, role-based, attribute-based, or policy-based access. It will revoke the access granted to employee on request. Once all access has been revoked, his identity record will be archived. Let us see how the access request workflow is implemented in CyberShield. Apart from access granted to users based on provisioning policies, users may also request additional privileges or permissions, which may go through an approval process before it is granted. The user will fill out an access request form. He can choose access from the catalog and provide a business justification for the request. On submitting the request, the IAM system will create a task for approver or chain of approvers. The approver will fill out an approval form, and he can either approve the request or deny the request with justification. If the request is denied, user will get a notification. If the request is approved, the IAM system will trigger the provisioning engine. If the application has a configured provisioning connector or agent, the request will be fulfilled automatically. Once the request is fulfilled, user will get a notification. In the absence of a provisioning connector, a provisioning ticket can be created in the ticketing system by IAM system. In this case, the provisioner or application admin will provision the request manually. We have seen how an identity management system can be implemented within an organization. Now let us have a look on the benefits that organizations will get. Enhance user experience. IDM enables end users to access corporate systems regardless of their location, time, and device. Reduce tickets. IDM offers self-service features that help implement best practices, reset passwords, update passwords, and request access, which reduces the burden on the help desk. Enhance security. Rely on IDM to ensure the right access to the right individual in the right context. Improve business agility. IDM allows easy, secure access to various systems without creating additional security silos, thereby promoting agile business. Stay compliant. Ensure to stay compliant to remain risk-free. IDM solutions help comply with ever-changing data regulatory requirements. Cost savings. Dealing with access-related issues adds to the cost burden. Leverage IAM to automate these tasks. This is a list of a few market-leading identity management tools. Disclaimer: we do not promote the tools mentioned here. Evaluate them as per your requirements, implementation timelines, and budget. The list is just an indicative list, not the full list. That's all folks for this episode. The next episode we will have an overview of access management. This episode is presented by Ashish Shrivastava. Ashish has 24 years of experience in cybersecurity. He has worked across industry implementing identity and access management solutions for customers in banking, finance, insurance securities, pharma, retail, travel and transport industries, which includes Fortune 500 companies. If you like this episode, please like and subscribe to this channel.